Hello everyone, welcome to my YouTube channel, and in this video we'll be performing image classification over Cipher10 dataset with simple ANN. But unlike last video, we'll be using PyTorch Lightning by Lightning AI. This is built on top of PyTorch, but it is fast, easy to use, and makes us comfortable, eliminating all the unnecessary lines like in core PyTorch. This is the official website of Lightning AI. Without further ado, let's jump right into the Colab and install PyTorch Lightning with pip. So like I mentioned here, I am installing PyTorch Lightning with pip. So if it is not installed in your device, you can install it with pip. Here we are importing all the important libraries like Torch Vision, OS, and only new thing that is added is PyTorch Lightning SPL. So this part is also copied from the last video. Like the transform is the same, and the dataset is Cipher10 downloaded from the official dataset hub, and we have defined data loader in criterion as a cross entropy loss. The model architecture will also be same with 3 linear layers, and it's passing through the railway activation function. So something new will be from this part. So what we need is we have to implement the PyTorch Lightning portion from this part. So for that I am going to create a new class lit simple ANN. So we the base class will be light. This will be same self model. So what this means, we will take this model as the input to this class self that model is called a model I'm going to create a function for them to define the training step. So it will take a batch and batch idx. So xy will be from batch. So x will be images and y will be labels associated with it in each batch. So when we feed the input image to the model, it will give the output self.model x. So the we calculate the loss criterion cross entropy loss out in y. So the output and the y will be calculated, will be passed to criterion. The criterion will be an cross entropy loss, and from that we calculate the loss. So we also need the prediction, the maximum class, the class with maximum probability distribution that will be used to calculate the accuracy. We did the same thing as in the last video, so nothing new. Argument argmax out dimension will be 1, then accuracy will be towards sum prediction is equal to y that item. So that means if the argument, the class in the input class and the output class are the same, then we add up 1 to the and divide by the total number of y. So in that case, in that way accuracy can be calculated. So self.log is something new that we haven't used in the last part. So what this does is it logs the loss in each step and each epoch, so that can be used in the later part for the plotting. On epoch is called true self dot log train accuracy on epoch is called true. So if you don't want to calculate loss and accuracy on each step, what we can do is on step is called false. By default it is true. So at end we simply return the loss value. Also we need to do is we need to configure the optimizer optimizers optimizers self. So what does the optimizer is called to torch.optim. So as we know, we also use SCD in the last video, so we are also using the same METERS mat parameters. Learning rate is called to 0.001 and momentum will be also same 0.9. Simply we can return optimizer. So PyTorch Lightning trainer handles all the hassle training loop. We simply pass the number of epoch we need to train our data. Here I have mentioned 10. We pass the model number, data loader, CSV logger to store the logs in CSV file. Boom, the training loop will start. How is it, right? The trainer is currently training all the data, and meanwhile we know we get the matrices to the CSV files saved in log folder. So let's go to plot graphs out of this. This is the plot with the training loss and accuracy per step in epoch. Along with this, I write articles on my website, link in the description. You can also check there also. I'm also associated with a margin tab solution. We provide all kinds of IT solutions. Do check us if you are seeking one.